Hello guys, welcome back. So in this lecture, we are going to see the example of recursion which we have worked on in the last lecture, right? In the last video. Okay. So in this lecture, we are going to see like how it works in the call stack in JavaScript engine or in the browser, we can say, right? So first thing, I want to tell you like why we need it, why we need recursion. So the keynote here is like recursion is almost everywhere. If you have ever used like json.stringify, json.parse, they also use recursion. If you have used like object parsing methods like object stringify, okay, and something like that, those also use recursions. Okay, so Java, like recursion is used in almost every place. So if you don't know, if you have basic idea, or like if you know about the recursion, then you will easily understand like how that particular mechanism or how that engine is working. Okay, because if you like if you are interested, you can do your own research like how the like JavaScript JSON stringify function works, right? Is it working recursively or not? Okay, and another example I would say is like that DOM methods, right? Document dot get element by id, document dot set like add text content, something like that. Okay, so DOM also uses like recursion. Okay, so it's almost everywhere, and at the end of the day, it's like your personal preference. Like if you're interested, you can go ahead and you can check like how they work internally. Okay, then you will find out like they are also using recursions. Okay, so recursion is almost everywhere. So if you know about recursion, then you will easily understand how a particular engine or how a particular code is working. Okay, so that is why it is important to know about the recursion. Okay, so this is about like why we need to know recursion. Now let's talk about call stack quickly. Okay, so here I have added few notes. So yeah, so let's understand about call stack, like how it works and why we need call stack, why we need to understand call stack in terms of recursion. Okay, so call stack is basically found in JavaScript engine. Okay, if you know about JavaScript, if you know about JavaScript engine, then you must already know about call stack, right? So in call stack is basically used to manage the function calls. Okay, so if you think like if you have wrote like let's say 3 4 functions, okay, how JavaScript will decide which function it should call first and which function it should call at the end? There is no way, right? So that is why to keep track of like function calls, to keep, or we can say to manage the order of the function calls, there is something called, there is a data structure called call stack. Okay, which is basically responsible to manage the function calls. Okay, and one more thing you have to keep in mind, the call stack never like in call stack your function never gets added whenever you write a function. The in call stack your function only will get added when you try to call your function. Okay, we'll dive a little bit deeper in a minute. Okay, now let's read the points and then we'll start understanding the call stack. Okay, and then we'll see like how it works with the example of recursion which we have written in the previous lecture. So follows the stack data structure. Stack is something like where we keep a stack of data, and we learn about stack data structure in one of the upcoming videos. Okay, so don't worry about that. For now, you just have to keep in mind. So it uses, call stack uses stack data structure. Stack you can think of like a stack of book. So in back in school, like whenever you guys submit the books, you used to keep the books one, like you used to keep the copies one over another, right? So that is what we call a stack, right? Now the call stack is like it manages the function calls, which one should execute first and which one at the end. Okay, so call stack is basically responsible for managing the order of the function calls, right? So it decides like which function should be called at the end, which function should be called at the very beginning. Okay, and it's a built-in in JavaScript engine. So you don't have to worry about this. It already comes up with the JavaScript engine. It is a built-in feature in JavaScript engine, right? Now when you write a function, nothing happens, but when you call that function, it gets pushed to the call stack. Okay, so whenever you are writing a function, if you're not calling it, nothing happens in the call stack. Okay, you don't have to worry about anything. It only matters when you call that function. Okay, as soon as you invoke that function or call that function, it get pushed to the call stack in the form of execution context. Okay. And yeah, right, we write a recursive function, we keep on pushing the functions into the call stack. Why we need to understand call stack in terms of recursion? Because in recursion, if you might have seen, like, we are calling a function multiple times, right? So it's important to like maintain an order of the functions which you are calling through recursion, because in recursion we also don't have any idea like how many times this function will get called, right? Okay, so that is why call stack is important in terms of recursion. Okay, so let's say you wrote a function. Let's take an example of this one. Okay, so here we wrote a function where we are calling this factorial. Okay, and if you pass 5, then this function will get called 5 times, right? So that is why, like, to manage the order which function should get called first and which function should get called at the end, to manage these orders, the call stack is important. Okay, for recursion. Now call stack is LIFO data structure. So LIFO, like, if I give you a high level overview, LIFO is something like last in first out. So let's say in back in school, you guys used to submit your copy to get checked with your teacher, right? So whoever like how the teacher checks the copy, sometimes it's like on the teacher's state of mind. Like sometimes they started checking from the like very bottom, sometimes they start checking from the very top. Okay, so the student who have put his copy on the very top, it gets checked first, right? So that is what we call last in first out. Last copy was submitted, it got checked first. Okay, so the last data came in and it got checked and it got removed from the stack. Okay, so that is what we call last in first out. Now, let's try to understand this with some visuals, right? And then we'll dive into our example, okay? Because then only you guys will understand it way better, okay? Right. So, yeah, let me quickly go into the screen, okay? So, here we go. So, let's say you have wrote 4 functions, okay? Function A, function B, function C, and function D, okay? And these are the function calls. Okay, so this is our call stack in JavaScript engine, and this thing we can consider as the execution context. Okay, so what will happen? Let's say you are calling your functions in this order. Okay, so let's say you are calling function B first. Okay, so what will happen? An execution context will get pushed into the call stack that will be for function B. Okay, let me quickly, I think I have to, 1 second guys. Okay, so this way. Okay, so function B get called and its execution context got pushed into the call stack. Okay, with this also I'm not familiar, so apologize for that. Okay, now you are calling the second function which you are calling is function D. So what will happen? Again, a execution context will get created for the function D, right? So 1 second guys. So these are the things which I'm just experimenting, so apologize for that in advance, right? Okay, so as soon as you call the function D, the execution context of that function will get pushed over function B. Okay, so as you can see, it is sitting at the top of function B right now. Okay, now if you call the function A, okay, so as you might have guessed already, what will happen? A new execution context will get created for function A. Okay, and then same will happen for function D. Okay, let me remove it. Yeah, now if you call function C, let me stretch it a little bit. Okay, so now what will happen? A new execution context for that function will get created in the call stack. 1 second. Okay, so this is how the function will get created. So the first function, the very first function which we have called is sitting at the very bottom of the call stack. Since the call stack is last in first out, so the function which got called at the very end, it is sitting at the top. And once it is finished executing, or let's say you have some return statement in that function, so whenever this function is returned, the execution of that function will get popped off the call stack, and then only the function which got called after before this one will start executing. Okay, and then it will process this function, and here it, if the call stack finds the like return keyword, then also this function execution context will get popped off from the call stack. Same will happen with this function, and then at the end same will happen with this function. Okay, so this is how the functions get pushed into the call stack and that get popped off the call stack. Okay, so this is the visualization. Now let's understand how it works, how recursion works in case of, like, how the call stack works in case of recursion. Okay, so here what I will do, I'll simply remove all these things. Okay, these console logs. Now to simplify it down a little bit, what I will do, I'll simply store the value which we are getting from here, okay, into a variable. Let's say current number returned from this factorial. Okay, and then what we will do, we will simply multiply this number here. Okay, so this way you guys can clearly see what is happening. Okay, because if I add the debugger here, then you will get no idea like what is going on, right? So now let me quickly format it a little bit. Okay, so it's formatted now. Yeah, so I think you guys can see it, right? It's zoomed enough. Okay, so now let's see how the like how it works in terms of call stack. Okay, so there are two ways to debug it. The one way is you can add debugger right here like this. Okay, if you add a debugger and then if you run it like this, let's say 5. Okay, then what will happen, it will start showing your function in the debugging console. Okay, in the browser, something like this. Okay, and then if you play, then it will keep on executing the things. Okay, so this is how it works. Okay, so this is something which I won't recommend you guys, because you are directly changing something in the code, right? And this is not good, because sometimes what happens, you write a debugger and then you forget, right? In case if you are working in a big project, right? So that's not an ideal solution. But I wanted to show you like this is also one of the way in which you can debug it. Okay, so now the other way is, let me quickly zoom out a little bit. Okay, now the other way is, so you are seeing console, right? And then you are seeing the sources tab. So you have to go into the sources tab and then use Control P in Mac, Command P, and then search for your file. So right now my file is script.js. Okay, so here I got the script.js. Okay, so I'll quickly expand it. Okay, here as you can see, so for now we don't need that window, right? So now as you can see, we are getting our code which we have written in our script.js file, right? This function basically. What I will do, I'll simply add a debugger here and here. Okay, now you guys have to keep keep an eye on the code, like how it runs. Okay, so here in the browser we have the call stack. Okay, so here you can see like how the execution context are getting pushed into the call stack, and here you guys can see what is the current number, what is the value of the current number and how it is getting changed, right? So let me zoom in as well a little bit so you guys can see. Okay, so now what I will do, I'll simply call this function. Okay, so this is a console, here I'm calling this function. So expected thing is it will call the function 5 times, right? So there will be 5 execution contexts. Okay, so it came into our debugger since the number is 5. Okay, number is 5 in call stack. As soon as I called this function, an execution context got pushed into the call stack. Okay, and it is pointing on the arrow as well. Now since the number is 5, it is not going into the if condition. Again we are calling another number. Okay, here what we will do, we will do 5 minus 1. Okay, and it will get stored into the current number returned. Let's see what happens. Okay, so as soon as this function got called, a new execution context got pushed here. As you can see, this is the one. In this one we have number 5, right? So it was called like here. Whenever I called that function here, this execution context got created. But as soon as this function got called with the value 5 minus 1, that is 4, this execution context got created, and the value of number is 4 here. Okay, so as you can see here, the value of number is 5, here number is 4. Okay, now 4 is also not equal to 0, then again it will call this factorial, right? So if I play it again, a new execution context got created, right? And by now you know how it got created, why it got created, because again a function call happened with the number 3, right? Because 4 minus 1 is 3, so it called the function with the number 3. So as you can see, the first execution context have the number 5, the second one have the number 4, and the third one have the number 3. Okay, now if I play again, a new execution context is getting pushed into the call stack, right? And this time with number 2, because 3 minus 1 is 2, right? If I push again or if I play it again, then a new function or a new, sorry for this guys, okay, a new execution context got pushed into the call stack. 1 2 3 4 5. Okay, so we have 5 what to say, execution context. Okay, now since we are getting 1 here, now the current number returned is 1. Okay, now what will happen, it will start popping off the execution context one after another, and it will start from the top, right? So right now the number is 1 and the current number returned is 1. So you have to keep in mind, whatever we are returning from this function will get stored into the current number returned, and the values you can see here clearly. Okay, in case you are getting confused, you can see the values here, what is the current number returned and what is a number, and we are multiplying that number and we are returning back out of the function. Okay, so right now current number return is 1, number is 1, so 1 into 1 is always 1, right? So it will get returned from this function, and then the execution context of that function will get popped off the call stack. Okay, so 1 2 3 4 5, we have 5, right? As soon as I play it, as you can see, the execution context of that function got popped off the call stack. The last one, okay, got popped off the call stack, and now we have just 4 execution contexts remaining in the call stack. Okay, now the current number returned is 1, because 1 into 1 was 1, right? And here in the previous execution context we had number 2, right? If you remember, so in the in the previous execution context, which was called right before the last execution context, last function call, okay, so it had the number 2, so 2 into 1, so here we have 2, here we have 1. Okay, so 2 into 1 will return 2, right? So now this execution context will return 2 out of this function, and then the current number returned we will have 2. Okay, and the number value we will have 3. Okay, why we will have 3? Because 3 is stored as a number for the previous execution context, right? So as you can see right now, the value for this function is unavailable, but as soon as this execution context get popped off, the value we will start getting here. Okay, whatever we are returning here will get stored into this variable, and then the value for this function will be available. Okay, so let's pop off this call stack or this execution context, sorry. Okay, so now the current number returned from that function, that execution context got popped off. Now we have just 3 execution contexts, right? So as we have seen earlier, it was giving us the value is unavailable, right? But now the value is 2, because this 2 got returned from this function, right? If you see here, current number returned we have 2. because this number have returned 2. Okay, and then it got stored into the current number return variable, and then we are multiplying that number with the current number. So current number for this execution context we had 3. Okay, so now 3 into 2, it will give us 6, right? So we will multiply this number and then we will return this number out of this execution context. Okay, so as soon as the JavaScript will see this return keyword, it will execute this execution context, or it will remove the execution context from the call stack, or we can say pop off the execution context. Okay, now this execution context will get removed, and then 3 into 2, 3 2s are 6. Okay, 6 will be available as a value for this execution context, which is holding the number 4. Okay, so here we will get 6 as the return value from this execution context, or we can say from this function call, right? So now let's return this function. Okay, so we have returned that function. Now as you can see, we are getting 6 here as the value, which is returned from this function. Okay, from the previous execution context, right? So now this function have, this execution context have current number 4, and then the value which returned from the previous execution context is 6, right? Now let's see like the last execution context. Here we have number 5, okay, which we have called at the very beginning. Okay, so this holds the value 5, and then the value for this current number variable is unavailable right now because we haven't returned anything from this function, from the next, like what to say, the latest function call, right? So as soon as we return this function, okay, we will start getting the value here for the current number return. Okay, now right now the current number return is 6, and then the current number is 4. Okay, so it will get multiplied, and then 6 4 24, 6 multiplied by 4, it will return 24. Okay, so this function will return 4 into 6, right? Because okay, so it's already started calculating it. Wait, so here it is 4, here current number is 6, so if you select all, then it will start returning 24, right? And that is what we are going to get in the last execution context, right? So let's pop off this from the call stack. Okay, route. Now we are getting 24, right? And the current number is 5. Okay, I hope like by seeing the call stack, how the execution contexts are working internally, you guys have got the idea like how the recursion will work, right? How our code is working. And that is what I have explained in the previous lecture, but I have just gave you the examples, right? But right now we are seeing everything, it is the exact same thing but in the call stack. Okay, now let's see. Right now we had 24, which is written from this function, right? And then it got stored into this variable, and then it will return like current number is 1 second, current number is 5, and then current number returned is 24, right? Now it will give us 24 into 5, 120. Okay, so now it will give us 120, and that is the factorial of 5, right? So as soon as I click on this click on that play button, see our call stack is empty now because we have nothing in our call stack. All the functions have returned, right? And since we are not storing anything, okay, so here we got the value 120. Okay, so if you don't look at the call stack, you will simply see like I have called this function like a layman. If you see this function like a layman, then what you will see, like I have called this function with the value 5 and it is giving me 120. How it is giving, you don't know, but it is giving 120 somehow. But by now, after seeing the call stack, execution context, the values in the current scope, now I think you guys are crystal clear how the recursion works internally, right? With the help of call stack, and why call stack is important to understand in order to understand recursion. Okay, that is why in the intro video I have said like this is the broadest topic. Okay, the previous pattern which we have done there, the call stack doesn't matter that much. Okay, but to understand recursion completely, call stack does matter a lot, because if you don't understand call stack, how call stack works, you will get no idea like how it is getting called and how the recursion is working in this code example, right? Because I believe like whatever I have explained in the previous lecture, if you had no knowledge about the call stack, then you are getting confused like how it is returning, even if it is returning also, then how it is getting stored in the previous function, right? So now you have all the answers how it will get stored in the previous function and how you will get the value, okay, returned at the end. So yeah, this is the recursion with the help of call stack. Now in the next couple of lectures we'll see like different types of recursion functions. So it's nothing like everywhere we'll be using like same terminology or same way of writing recursion, but we will see like how what are different ways of using the recursions. Okay, so this is it for today. I hope you guys might have found this lecture interesting. Okay, so there is nothing to attach in the like what to say in description like code snippet. If you want, you can see the video and you can change your code accordingly. Okay, so you can also like remove all the console logs and you can store this function into this variable and then you can multiply it with the number. Okay, this is just a small change. Okay, and then what you can do, you can simply add the debuggers like this. And see, the benefit of adding debuggers here is you just simply click on it, the debugger got added, and you simply click on it, the debugger got removed. Okay, so this way you don't have to change anything in your actual code. Okay, so yeah, this is call stack with the help of recursion in a nutshell. This is it for today. See you in the next one.